Hi guys, welcome to video 6 of iSTAND's Biodiversity and the Senses series. So the first sense that I'm going to talk about is proprioception. Yay! In our first few videos, we talked about the main 5 senses that you guys have probably learned a lot about in school, as well as in the videos that we've just shown you. But I'm going to talk to you now about some other senses that we don't really talk about a lot, and they're really important senses for us in our daily lives. Have you ever wondered how you're actually able to feel where your body is in space? If you were to close your eyes right now, and be careful not to knock your neighbor out, if you move your arm around your head, you can still feel where it is next to you, even though you can't see it. And if I take my 2 fingers here and keep my eyes closed, I can still get my 2 fingers to touch. So the reason I'm able to do that is because of my sense of proprioception. Proprioceptors are the little receptors that are in our muscles, as well as the connective tissue in our joints. And these little receptors tell our brain where our body is in space. So it's a pretty weird word, so we'll just go through some of the pronunciation. It kind of sounds like proprioception. So it's a 5-syllable word, and then the receptor for those is called proprioceptors. The other sense that works with proprioception to keep our body moving in space is our sense of balance. So our proprioceptors are able to help us balance by letting our brain know where our body is. So if I go up on one foot right now, my brain can still tell that my other foot is off the ground and floating beside me. But then the way that my body actually stays upright is the little receptors in my inner ears here, and this is called your vestibular system, actually tell my brain where my body is relative to the floor that's underneath me. So if I start tilting one way, my vestibular system in my brain starts telling my brain which way my body's tilting. We can trick our vestibular system. So if you guys have ever gone on one of those spinning rides at the fair, or even if you just go outside during recess and spin around really fast and you start to feel dizzy, that's because your vestibular system got tricked into thinking that you were spinning when you really weren't. So in Canada, we have some really cool animals that have really awesome sense of balance and proprioception. So if you've ever seen a squirrel, you know that they have an amazing sense of balance. That's due to their vestibular system, as well as the way that their body is shaped, because they have the big tail that lets them balance like a tightrope walker with a big stick. We also have some really cool cats in Canada, the lynx and the cougar. I'm sure you guys have heard that cats always land on their feet, and that's because of their amazing sense of proprioception. So those little muscle receptors that I was talking about earlier, cats actually have a ton of those all throughout their body, and that's why they're able to always reorient themselves when they're falling and make sure that they always land straight up and down on their feet. So in our lab at UBCO, we have a lot of really cool equipment that lets us test our sensory systems. And what I have here is a little vibrating wand that when I touch it to somebody's muscle, it actually tricks the receptors in that muscle into thinking that that body part is moving, and that causes the central nervous system and the spinal cord to then resist that movement. So when I touch it to Corey's arm here, what's going to happen is her receptor is going to think that her arm is being stretched down as hard as it can. So what her body is going to do to counter that stretch is to pull the muscle back the other way. Okay, so let's watch. Corey's going to close her eyes, and she's going to just try and relax her body as much as she can. So you see there that Corey's arm got raised up a little bit, and that wasn't Corey doing that. That was just all activity in her nervous system that she wasn't actually conscious of. So with Corey's arm muscle, what we did with the tendon vibrator was we tricked her proprioceptors into thinking that her arm was being stretched down. So what her muscle did in response to that was pull back against it and moved her arm back up. We're going to do the same experiment, but this time on the muscles on the back of Corey's leg, and then we'll see what happens. So what we're going to do is we're going to put it right up against the back of the tendon on the back of Corey's leg. Thanks, guys. So what we saw right there was the tendon vibrators actually caused Corey's calf muscles to contract because the sensory information that was going up to her spinal cord was telling her body that, oh no, I'm falling forwards, I better push back as hard as I can so that I stay upright. But since Corey was already standing upright, it actually just pushed her straight back into the chair. So what you guys are going to do in your classrooms now is actually be able to trick your own proprioceptors. So just like I was tricking Corey's. You're going to go stand under a door frame, put your arms to the side with the back of your hands up against the door frame, and you're going to push as hard as you can against that door frame for 30 seconds. After 30 seconds, I want you to take a big step forward and see what happens to your arms after you've stepped away from the door frame. So for this next activity, we're going to look at how our eyes, so our visual system, and our proprioceptors and balance system in our inner ear keep our body standing upright. So I'm going to have you can just do this at your spot in the class. I'm going to have you stand normally, 2 feet, and just stand there for 10 seconds and see what happens, okay? Once you're comfortable, I'm going to get you to try and close your eyes. I just want you to feel how your body moves. See if it's moving a lot, is it moving a little bit, or is it not moving at all? Now I'm going to try having you stand on 1 foot with your eyes open for a few seconds and see how that feels. And then after that, I want you to try it with your eyes closed and see how long you can stand upright with either your eyes open and eyes closed, and which one is easier.
Well, thank you for joining the UBCO iSTAND team as we've explored the 5 senses and proprioception and balance. On behalf of the team, the Owens, Corey, Maxine, and Eli, we'd like to thank you, I'm Jen by the way, for joining us this past week for Science Literacy. We hope you've enjoyed it. Thank you.